Integral 0 to 3 e power x plus e power minus x by step x factorial dx we have to find, where step x is what here, greatest integer function they mentioned clearly. Okay, that to the limits from 0 to 3. So observe here, when you take from 0 to 3, let's divide like this, up to 1 and up to 2. 0 to 1 if you take any value, and if you are applying step function, you will get result is 0. Similarly from 1 to 2 if you take any value, applying step function is 1. Similarly from 2 to 3 if you take any value, applying step means you will get result is 2, because that's the greatest integer function. Okay, now let's divide the entire integral as like this. 0 to 1, one part. In between 0 to 1, step x value is what, 0 only na, right? So 0 factorial means it will be 1 only, we know that. So it will be 1, then you will get e power x plus e power minus x, denominator 1, no need to write, dx, plus integral 1 to 2. If you take any value from 1 to 2, if you are applying here, if you are applying step function, you will get result is 1, and 1 factorial is again 1 only. Then also you will get e power x plus e power minus x dx. Next from 2 to 3. From 2 to 3 if you take any value, if you are applying step function, result is 2 only. 2 factorial means again 2. So you will get e power x plus e power minus x by 2 dx. Okay, now let's integrate this one. E power x integration, e power x, e power minus x integration, minus e power minus x, you will get limits from 0 to 1. Similarly, there is no change in integration, right, as it is even here also, but the limits are 1 to 2. Similarly here 2 is there denominator, so 1 by 2 is a constant, and e power x plus e power minus x integration is e power x minus e power minus x, and the limits from 2 to 3. Okay, now substitute upper limit everywhere, every place of x first. So e power 1, that means e, minus e power minus 1, that means 1 by e, it is upper limit part, minus lower limit 0 substitution e power 0 1, and e power minus 0 means 1 by e power 0, so 1 by 1 means again 1, plus if you substitute 2, e square minus 1 by e square, it is upper limit, minus lower limit part e minus 1 by e, plus here 1 by 2 of, when you substitute upper limit, e cube minus 1 by e cube, it is upper limit part, minus lower limit when you substitute 2, e square minus 1 by e square we will get. Let's calculate this. So e minus 1 by e as it is we can write, and 1 minus 1 is 0, we will eliminate, plus e square minus 1 by e square, and here minus e plus 1 by e, plus here half is there, half 1 by 2 e cube minus 1 by 2 e cube, okay, denominator, minus e square by 2, minus into minus will be what now, plus 1 by 2 e square, like this we will get it. Okay, right, now see, minus c plus c cancel, 1 by e minus 1 by e also cancelled. Okay, now next remaining terms, first we can write here square, e squares how many are there, here 1 e square is there, and next here minus e square by 2 is there, so 1 e square minus e square by 2 means 1 by 2 e square we will get. Next minus 1 by e square is there, and here plus 1 by 2 e square is there, so minus 1 plus 1 by 2, minus 1 plus 1 by 2 means minus 1 by 2 only, no, so minus 1 by 2 e square is there. Next so these are over, the remaining terms are e cube terms. See now here half e cube minus 1 by 2 e cube is there, so here plus 1 by 2 e cube minus 1 by 2 e cube, like this it is there overall, right? So everywhere 1 by 2 is there, let's take it 1 by 2 is common. 1 by 2 taking common means now the balance terms are what, e square is there plus e cube is there, e square plus e cube. Next minus 1 by e square is there, minus 1 by e cube also is there, so this will be the answer. So observe options, 1 by 2 e square plus e cube minus 1 by e square minus 1 by e cube, option 2.